Now we'll see unit 2 short answers questions. Okay. The first topic is probability density function. Define probability density function. So remember this formula, that is the derivative of the distribution function or the derivative of the cumulative distribution function. So it has to be, you always remember density function represented with a small f, distribution or cumulative function represented with a capital F. And whenever you are writing, you should be remember that you need to write f x of x. This x represent the random variable and this particular value represent the one value or one element of the random variable. Okay, this small f represent for the density function. Always you need to write density function with a small f only. This is the capital X and this is the small x. Similarly, here also capital F x of x is the distribution function or cumulative function. Capital F x in bracket small x. So you should be very careful. Don't replace small x with capital X. Then entire meaning will be collapsed. Okay. So you write whenever they ask the density function. Density function of random variable x is the derivative of the cumulative distribution function fx of x. So that is the derivative d by dx of fx of x. Okay. So define probability distribution function, capital PDF or CDF, cumulative distribution function. So it is the probability p of x less than or equal to x of the event x less than or equal to x. Fx of x is equal to p of x less than or equal to x, where x is a real number in the range minus infinity less than or equal to x less than or equal to infinity. Remember this formula for 1 mark. Fx of x is the p of x less than or equal to x. And write the density and distribution functions of a different binomial, that is binomial, Poisson, uniform. These are the different density functions. So first we'll write the binomial. Okay. So the binomial, if x is a discrete random variable, the probability density function fx of x is equal to, so you can write this fx of x is equal to d by dx of fx of x. Normally we will write d by dx. This is the meaning is that x is equal to x. The probability of the random variable x at value small x. That is the meaning of fx of x. Capital Fx of x is the meaning of that p of x less than or equal to x, meaning that sum of all that is cumulative. Cumulative. So if you say cumulative attendance, normally we will say cumulative attendance means some. If I calculate the attendance at the, assume that you started your semester at the August. If I calculate September, cumulative attendance means up to September, August plus September. So here, whatever the values of x less than or equal to x, this is only at particular x. That is the difference between small f and capital F. So here, fx of x is p of x is equal to x. This formula you remember. Summation of k is equal to 0 to n nck. That is p power k 1 minus p whole power n minus k delta of x minus k, where p and k. If I want to write capital fx, you replace this delta with u. Okay. So next we will write for the Gaussian. Okay, Gaussian random variable. Fx of x is, at least you remember the formulas for the different random variables. 1 by root 2 pi sigma x square exponential minus x minus mu x whole square divided by 2 sigma x square, where sigma x square is the variance of the random variable x and mu x is equal to mean of random variable x. Okay, you remember this formula for the Gaussian random variable. And next for exponential fx of x is equal to 1 by b e power minus x minus a by b for x greater than a, 0 for x less than a. Okay, this is the exponential density function. Next we are having Rayleigh Rayleigh probability density function. This is exponential PDF. Okay, so fx of x is equal to Rayleigh probability density function 2 by b x minus a into e power minus x minus a whole square by b for x greater than a, 0 for x less than a. If you see, if you remember exponential, you can write that for Rayleigh. This is 1 by b, this is 2 by b. X by x minus a is multiplied, here x minus a whole square. You remember like this. This is for Rayleigh probability density function. And next, Poisson's. Poisson's probability density function. Fx of x is equal to so for Poisson PDF, fx of x is equal to e power minus b summation k is equal to 0 to infinity b power k by k factorial into delta of n minus k. Okay. For uniform, the probability for uniform random variable, the probability density function fx of x is equal to 1 by b minus a less than or equal to x less than or equal to b is equal to 0 otherwise. Okay, so these are the different density functions for random variables. Okay, define expected value of discrete random variable and continuous random variable. As the expected value means E of, first I am writing for continuous random variable. E of x is equal to integral minus infinity to infinity x into fx of x dx. Okay, so you remember whenever you are writing expected E of anything, so whatever the value, replace here with the small letters and multiplied with the density function. If I am having E of x square, assume that if I want to write E of x square, integral minus infinity to infinity x square into fx of x dx, like that. Okay, so for the discrete random variable, E of x is equal to, that expected value of the random variable is equal to, integration becomes summation I is equal to minus infinity to infinity xi p of xi. The density function replaced with the probability mass function p of xi and x as it is. So xi into p of xi is the formula for the discrete random variable. Define moments about the origin and central moments. Moment about the origin, E of x power n. So this is about the moment about the origin. So I told that no, whenever we are having expected value minus infinity to infinity x power n fx of x into dx. Okay. So if I want to write the central moments, moment about the origin means E of x power n. Central moment means E of x minus x bar whole power n. Okay. So that is integral minus infinity to infinity x minus x bar whole power n fx of x into dx. This is about the central moments, and that is moment about the central moment is called moment about the mean. Another name for central moment is the moment about the mean, moment about the origin. So this is also can be written as x minus 0 whole power n. Okay, so here about the origin, so that's why x minus 0. About the mean, x minus x bar whole power n, you replace as it is this capital X with the small x, and x bar is a constant mean. That's why I am writing as it is whole power n multiplied with the fx of x dx. Okay, So show that the zeroth moment is always 1. So here this is represented with the mn and this is represented with the mu n. The symbols for the moment about the origin is mn, that is the nth order. Mn is the nth order, mu n is the nth order central moment. N represents the order. Here what the zeroth moment is always 1. Okay, zeroth moment, they didn't mention anything about whether it is the moment about the origin or moment about the mean. You can take anything. So if I consider the moment about the origin mn, so if I take m0, so normally what is the formula for mn? Expected value of x power n. So m0 is expected value of x power 0. So anything power 0 is always 1. The expected value of 1 is 1 because expected value of constant is equal to constant. So that is E of A is equal to A, if you remember. E of one of the property of the expectation. E of A is equal to A. So that's why M0 is equal to, first write this formula. Mn is equal to expected value of x power n. And m0, that is the zeroth moment, m0 is equal to expected value of x power 0. X power 0 is 1, expected value of 1 is 1. Okay, represent average power and RMS value of the signal in terms of the moments. Okay, so first order moment is m1, zeroth order is m0, and second order is called the m2. Okay, so m2 is called the RMS value. Okay, so m2 is the RMS value. So m2 is equal to, so we know mn is equal to expected value of x power n. So m2 is equal to E of x square. So that is integral minus infinity to infinity x square into fx of x dx. Okay, this is called the second moment about the origin or mean square value. Okay, mean square value, and also it gives the average power of the signal, and square root of that m2 gives the RMS value. So this gives the average power. M2 is the second moment about the origin, and it gives the average power. Get average power or second moment about origin, second moment about origin or average power, and square root of m2, that gives the RMS value. Okay, show that the first central moment of x is always equal to 0. So we know that mu n is equal to expected value of x minus x bar whole power n. Okay, nth order. So first means mu1. mu1 is equal to expected value of x minus x bar whole power 1. So that is E of x minus x bar. Okay, now what we can do this one, E of x minus x bar. So the expectation can be applied to each and every function. E of g1 x plus g2x can be written as E of g1 x plus E of g2x. Like that I can write this as E of x minus E of x bar. So E of x is nothing but x bar. You can replace the expected value as the mean value. And E of x bar is x bar because x bar is a constant. X bar is constant, and E of constant is equal to constant. So that's why E of x bar is x bar. So x bar minus x bar is 0. So always the first central moment of x is always equal to the 0. Define moment generating function and characteristic function. So sometimes they may ask about the variance also. Variance is the, so here mu2 is called the variance. That is the second central moment is called the variance, that is represented with sigma x square. Okay, mu2, that is E of x minus x bar whole square, that is the variance. And the moment generating function, I think moment generating function and characteristic function. So characteristic function is represented with phi x of omega, that is equal to expected value of expected value of e power j omega x, e power j omega x capital. Okay, so if I want to write the formula, minus infinity to infinity e power j omega x fx of x into dx. I told whatever is there inside expectation, you write as it is here and multiply with fx of x dx. So e power j omega x into fx of x dx is the formula for the characteristic function. Moment generating function is mx of v, that is expected value of e power vx. That is the moment generating function. Characteristic function, if you remember this formula, then you can write automatically this formula. Expected value of e power j omega x is the formula for the characteristic function. Okay. And what is variance? And I just now I told you variance is equal to mu 2 and standard deviation is square root of mu 2. Okay. That is e of x minus x bar whole square. Okay. And sometimes they ask the relation between the characteristic function and the probability density function. Okay. So here I write relation between characteristic function and PDF, probability density function. Okay, so the Fourier transform of fx of x with that is, you can write fx of x is equal to 1 by 2 pi integral minus infinity to infinity pi x of omega e power minus j omega x into dx. Okay. Inverse Fourier transform of pi x of omega gives the PDF with the sign x reverse. Okay. The same thing, characteristic function is the Fourier transform of the density function with the reverse sign. So if you see the formula for the characteristic function, fx of x into, normally Fourier transform formula is f of omega is equal to minus infinity to infinity f of t e power minus j omega t dt. Okay, if you compare these two, in place of minus, here we are having plus. That's why writing characteristic function and density, probability density function makes a Fourier transform pair with a reverse sign of minus x. Okay, sometimes they will ask, write the relation between the characteristic function and the density function. You write this one. They form a Fourier transform pair and write the formulas. If you remember this formula, the same formula we can write for here, the relation between the characteristic function and density function. Inverse Fourier transform reverse. Okay. Next, show that variance of kx is equal to k2 into variance of x. So here we can expect so that, like one property may ask like variance of k is equal to 0, variance of ax is equal to. Okay, so we can't show that which property will get. Sometimes they may ask this type of properties are also as your 1 mark questions. Normally they won't ask, but they may ask as one of the property also to prove. Okay, so variance of kx is equal to a square into variance of. So if you know variance of x is equal to, what is the formula? Expected value of x minus x bar whole square. Okay, now we are having variance of kx. So in place of x we have to write kx. So kx minus kx bar whole square. That is expected value of k is constant, take outside. Okay, so k square x minus x bar square. Again k is constant, k square is also constant, you can take outside from the expectation, x minus x bar whole square. So that is k square into, this is nothing but the variance of x. Okay, so this is one of the property of the variance. Define skew and coefficient of skew. Okay, skew is the measure of asymmetry of the fx of x about its mean. Skewness is represented with nu 3 by sigma 3 whole cube. Okay, so skew definition you write first. Skew, and skewness is the Qness can be calculated as mu 3 by sigma 3 whole cube, where mu 3 is the third central moment and this Q is the measure of asymmetry of fx of x about its mean. Okay. When does the two random variables are statistically independent? When we can say two random variables are statistically independent, you can write this as the probability, that is the joint probability density function is equal to the product of the individual density functions, or you can write E of xy is equal to E of x into E of y. E of x is equal to E of x into E of y, or you can write joint density function of fxy of x comma y is equal to fx of x into fy of y, or you can write distribution function fxy of x comma y is equal to fx of x into fy. You can write any. Okay. What is the physical significance of variance and standard deviation? Okay, you write this one. So normally the variance is the how much it is spread from the mean value. So variance gives the square of the value and standard deviation gives the exact value. It is how much it is deviated. Both are the same. How much it is the value particular data point, how much sample point is deviated from the given mean. That is the average value. Okay. And some more point that when we will give the represent variance. One more question. Variance, relation between the variance. We are having u2 is equal to m2 minus m1 square. Okay, that is the relation between the central moments and moments about the origin. Variance, represent variance in terms of the moments about the origin. Variance in terms of the moments about the origin. Or relation between the, like that they may ask. You remember this formula is also very important. U2 is equal to m2 minus m1 square. Okay. Thank you.